Hi everyone, welcome to GemChem. Now today's video is on group chemistry part 3 video, where we are going to deal with the tendency of polymerization of these oxoanions. Now before starting, already 2 videos are uploaded in channel. You can watch it. I will give the link in the description box as well as the I button present about this video. And if you are new to GemChem, do not forget to subscribe the channel and hit the bell icon for regular updates. Now let us start. So first of all, from the previous video only, we know the structures of these oxoanions, right? So now we have to understand that what is the answer to this question. The answer is very simple, that is the extent of polymerization, that is the tendency of polymer formation, decreases as we move from silicon to phosphorus to sulfur to chlorine. So this has the most polymerization tendency, whereas chlorine has the least polymerization tendency in these oxoanions. Why this is so? This can be well explained using the concepts of periodic properties, which is very much essential. So you have to always remember all the things obtained while reading the periodic table chapter. If you want to recapitulate, you can watch the videos. I will give the link in the description box as well as the I button present above this video. So first point is that we can see that there is a gradual increase in electronegativity of the central atom from silicon to phosphorus to sulfur to chlorine, right? So if there is a gradual increase in the electronegativity, what happens is that the nucleophilic attack of oxoanions, that is this part, gradually tend to decrease, as a result of which extent of polymerization decreases. So if you can see, this is the most electronegative one, chlorine. So it will have the tendency to grab these negative charges towards itself. So if the negative charges comes towards the chlorine, then this oxygen will lack this lone pair's tendency to be donated to another one, as a result of which this will have the least tendency to form polymer. Similarly, next point comes is that greater the number of anionic oxygen sites, there will be greater probability of nucleophilic attack. And thus, we can see more polymerization. That is, if you see here, there is 4 nucleophilic sites of oxygen, whereas here it is 3, here 2 and here 1. So more the negative charge, more there will be probability to be attacking as a nucleophile, right? So it is for this reason that SiO4 4- undergoes polymerization to a greater extent, and this extent of polymerization decreases from SiO4 4- to ClO4- perchlorate. Just make a correction, this will be SiO4 4-, not 2-, right? Now the third point, that is the last point which is very important, is that when there is an increase in the pi bond formation from SiO4 4- to ClO4-, the nucleophilic attack of oxoanions will be sterically hindered, because there is a pi bond formation. Attack always faces a steric hindrance. As a result, there is also lowering of extent of polymerization. So when this question is asked, these 3 points are very much important to be shown and written in the copy, right? So this was the answer to this question. Hope this was helpful. In the next video, we will see the carbon's property of exhibition of extensive catenation, but this property is not being observed for boron and nitrogen. So this much for today. Thank you for watching. Do not forget to like, share, subscribe and comment.